Hey, welcome back to Fat Mama Physics. In this video, we are going to do another example on the conservation of momentum. And this time we are going to talk about gun recoil, or in fact, anything in which they start off with zero momentum and they kind of explode from both to either side. We have, starting from rest, okay, we got a pistol, a 2 kilogram pistol. I'm going to label this MP. It starts from rest, so the initial velocity of this pistol is going to be 0. It fires a 20 gram bullet, so that's going to be my MB right there, in which the bullet leaves the pistol with a speed of 150 meters per second. So that's going to be the bullet's velocity. But that is after the firing, okay? So we're going to divide the, instead of a collision now, we have some sort of an explosion event. So whatever that event is, we still need to talk about before and after the event, in which before we have the initial velocity of our whole system being 0. And why that is, before the firing, the gun wasn't moving at all. So in fact, the momentum, the combined momentum of my gun and my bullet is 0. After the explosion, or after the event, we have the bullet leaving, so I'm going to write VB for bullet, leaving with 150 meters per second, in which I'm going to label this direction of the bullet as the positive direction. Remember, momentum, directions matter. We need to calculate the recoil velocity of the pistol. So that's going to be my VP, and that's what we don't know. So going back to conservation momentum, we have mass of our mass pistol times the initial speed plus mass bullet times its initial speed, velocity equals to its momentum after. Okay, so here is what we have here. And since the initial velocity is 0 before the firing, we have those becoming 0. So then we're left with 0 is equal to mass of pistol times velocity of pistol plus mass of bullet times velocity, final velocity of bullet. Now we need to solve for the final velocity of the pistol. We're going to isolate it on one side of the equation by me subtracting this term first from both sides of the equation. Because my VB is with my MB, I can't just isolate VB by itself first. I have to bring the term together. Remember, they're tight sisters and brothers. Now I can divide both sides by the mass of the pistol. And what I've just done here is I moved the negative sign to the other side, so when I calculate this number here, I'm going to get a negative value, which makes a lot of sense because the recoil of my pistol will be in the opposite direction relative to the bullet. Putting in all our values, we get, and mass of the bullet here is 20 grams, and we're going to divide that by 1,000 to get kilograms, leaving us 0.02 kilograms. Putting all this into our calculator, we get 1.5, negative 1.5 meters per second. And since the question doesn't specify which direction is positive or negative, I'm just going to put a negative sign here to show that relative to 150, it is in the opposite direction. Okay, so here we have an example of recoil. And the interesting thing about recoil is the fact that before the event, both objects started at rest. Now it is your turn to deal with a similar problem. We have here an astronaut, kind of like the video I showed before, where he threw a basketball forwards. The astronaut's going to recoil backwards after the throw. How fast was the basketball thrown? Oh, and I didn't say this. Imagine this is in space, or in a space station. So you can ignore, friction and whatnot. Okay, so good time to pause the video to give this one a try. Okay, and now it's my turn to do the problem on Fast Play. Okay, we're gonna first off labeling some values here. We have the mass of the astronaut, 99 kilograms, mass of the basketball in 501 grams, converted to kilograms, that is divided by 1,000, moving decimal place 3 times over. Don't forget to draw before and after picture here. I have before the picture, before here, astronaut and the basketball were together. They are at rest at 0 meters per second velocity, but afterwards the astronaut is traveling backwards and the ball is traveling forwards. That's what we're trying to find. Forward direction I'm going to label as a positive direction, and since both objects are not moving to begin with, the initial momentum is 0, which I wrote over there. To solve for the velocity of the basketball, I got to move the astronaut term to the other side, dividing both sides by the mass of the basketball and calculating it out, we get a total value of 8.89, which rounds to 8.9 meters per second, but in the forwards direction. Okay, and here are the solutions to example 4. And I shortened a few steps here in which the initial momentum here is 0. I just put a big fat 0 on the before side. And the after side, we'd have to do some conversions for the mass. Basketball is in grams, so we're going to convert that to kilograms, moving the decimal place 3 times, 1, 2, 3. Multiplying everything out, we get 9.8 meters per second, and the basketball is moving forwards. I chose the backwards direction being negative. So don't forget to include directions for your vectors when you write your answers to your problems, okay? Great job, guys! Thank you for watching this video. Hope you learned something in this problem that you can apply yourself. Good luck, and Fat Mama Physics signing out.